Hey, and welcome to another day of Code Along with Me, the 100 Days of Python Challenge. I'm Bill Mosley. If you want to get the starter code for this project, you can find it at the 100 Days of Python portion of my website, which is bmosley.com/hdp. You can also find a link to the website in the notes for this video. And so let's get started. We're on day 21. And today we are going to be making a project that I like to call Infinite Snowflakes. And it's kind of a fun project because we are going to be using um, functions that are calling other functions, and all of those functions are ones that we've made. And so the end result is going to be the ability to create an intricate design at different scales. And the cool thing about that is that we can use that along with some tricks of color to provide the illusion of sort of being in a snowstorm where the snowflakes are up close and visible and far away by scale and more sort of blending into the background. So this is kind of a fun project, and I hope you enjoy coding along with me. So the first thing we're going to do is we're going to start with this starter code. And you'll notice right now that everything is commented out. And the reason for that is because I'm going to uncomment it as I talk about it and sort of walk you through what this starter code does. So you can see here, we've got several custom functions that are being made. And so we're going to start right here at the top with the make diamond function. And it's giving me errors right now when I uncomment it because we don't have the turtle imported yet. And so what I want to do is from turtle import all. And there's that. That takes care of a lot of the underlining. We also have this variable called int scale. Right now, I'm just going to create int scale manually and set it equal to 1. And that way we don't have to worry about it. It doesn't really have any sort of impact on any of the code so far. And that allows us to kind of play around with some of this stuff. So this first function simply makes a diamond shape, and sort of this is going to be part of, or one of the building blocks of, our snowflake shape. So the first thing we do is make diamond. And so if I run that, or if I call that function in the code, make diamond, and I'm going to throw all the way down here at the bottom, I'm just going to say done, which will keep the window open after it finishes. So I've just declared a function, and I'm going to call the function. Notice it's got no parameters, so I don't need to provide it with any arguments. So let's run that and see what happens. There it is. And not much visible there. And the problem is that we have some very small shapes happening. So I'm going to go ahead and scale it up using that int scale variable. I'm going to make it a 10. Let's run it again. Okay, so there is the diamond shape that we've been talking about. And this is going to be sort of the very tip of each arm of our snowflake. And so that's that part. And so that's good. We've done that. Let's go on to the next function and see what's going on here. This one is called make end. And I'm going to uncomment that. And make end is another part of our snowflake. And you can see we're going to be building our snowflake one piece at a time. But the nice thing about using these functions that are inside of other functions is that it makes each one a little bit smaller and more manageable. So instead of writing all of this code right here in place, I just have the make diamond. Now, I know that make diamond does these things. So it sort of represents what it does, but in only one line of code, which makes all of the code a lot simpler. So let's see what it does. Let's see what make end does by running it and calling just that function. And so if we look at that, there is the end of my snowflake there. Looking good so far, right? I like it. It's allowing me to create an intricate shape, right? So there's that. And let's see what's next. Okay, so there's another little function here called make short bump, and you can see that this doesn't refer to any of the previous functions. It doesn't use make end or the make diamond function, and it just has some code in here. And so I'm going to actually skip here to the very end here, and it says make arm. And make arm, you can see, has some instructions to direct the turtle, but it also uses make short bump and make end. And remember, make end also uses make diamond. So this is actually going to produce a fairly intricate design. And I'm going to make it a little bit smaller. Let's make it a little bit smaller. Let's scale it back down to 5 so we can make sure it fits on the screen. So we've got that, and uh-oh, it's not doing anything because I forgot to call the make arm function. Just kidding. There we go. Now when I run it, it will actually make an arm. Okay, so there is an arm, and you can see here, this is the make bump right here. That's called twice, and then we have the make end. So it makes a nice little snowflake pattern, or an arm of a snowflake. Now, if I want to make a snowflake pattern, what I would do here is I would say, how many arms should a snowflake have? Let's start with 6 and see how that goes. For x in range, so I'm going to set up that loop so it goes 6 times make arm, and we will say, you know what, I'm going to set up the angle here too. So let's say int arms. So int arms equals 6. And then right below this, we are going to do FL angle. And we're going to set that to 360 divided by the number of arms. And then we are going to actually add 180 to that. And the reason we do that is because the direction of the turtle when it finishes is going to be opposite the direction we want it to be. So that turns it 180 degrees, and then whatever else, whatever 360 divided by 6, in this case it's, of course, 60. So it'll turn a total of 240 degrees, in this case, between. And so we'll put that in here, FL angle, and let's give it a shot and see how it works here. So it'll draw the first arm and hopefully turn in the correct direction for the second one, and there we go. So this will continue, and it will draw the whole snowflake, and we're looking pretty good so far. Now, obviously, this is a fairly large snowflake, so we want to think about maybe scaling that down a little bit because that's very, very big. And if we're drawing a scene here with multiple snowflakes, it'll just take a couple of these huge ones to kind of mess it up. So we don't really want anything that big in the foreground. So we've still got a little bit of work to do here, but we're making some good progress. So let's quit that and let's go on and look at the next thing here, which is scaling that down a little bit. And so probably what we want to do is we want to scale this back just a little bit. So we'll probably want the biggest to be about 3. And let's see what that size looks like. Okay, so that's looking pretty good to me, size-wise, as far as the biggest ones go. And so now we just need to begin the process of drawing those randomly scaled snowflakes all over the screen. So that's kind of the deal there. And so this draws 1 snowflake. And so what we're going to need to do is we are going to need to introduce an element of randomization. And to facilitate that, I'm going to take this scale variable down here and I'm going to put it there. And even though you'll notice that before I paste it in, all of these functions are having issues. And when I paste it in, even though it's defined after the functions are defined, as long as this is defined before the functions are called, then we're okay. Okay, so that's kind of the deal there. So now let's create an infinite loop while true. And we're going to do all of this in here. So that's a pretty good start. And I want to randomize the scale here. So the scale is going to be randomized. Let's say I want to give it a random integer between 1 and 3. Actually, let's do this. Let's go between 1 and 9 and divide it by 3. And I know that doesn't give us an int, and all these say int scale, but we're going to, well, actually, let's just do this. We'll just do a replace, and we'll say int scale, and we'll replace it with FL scale, because we're going to have that be a float now. So we're going to replace all the instances of that. Now we can see it says FL scale everywhere. So what we're going to do is we're going to say, first we need to import random. So we're going to say import random up here so we can use that random module. And then we will say random dot rand int, and it's going to be between 1 and 9. And then we're going to take that and we're going to divide it by 3. So it could be as low as 1/3, it could be as high as 3. And we'll have 9 steps or 8 steps in there. So that's how that's going to go. And that's how we get scale. And so that's working pretty good. Let's just check that, make sure it's going to work the way we want it to. Okay, so we've got our little snowflake design here chugging away, and I think it's going to work because that's a smaller scale. So if it wasn't going to work, it would have had an error already. But let's just stop that for now. We don't want to spend too much time watching it run because you can do that at home. What I want to do is I want to also create a way of tying the scale to the color. And so I'm going to grab a couple of colors here and then we'll use those. So I'm going to flip on over here to this page that shows me the colors. And this is trinket.io/docs/colors, a great page for looking up color names. And I'm going to pick the colors that I want. And for these snowflakes, I'm going to go, the lighter colors are going to be the ones that are the smaller. And then the medium-sized ones will be light cyan. So we've got azure, light cyan, and pale turquoise are the colors. So I'm going to use those names, and I'm going to keep those in strings here. But I'm going to use the size of the snowflake, or the scale, to determine those. So what I'm going to do is I'm going to say if FL scale is greater than 0, and FL scale is less than if it's less than 2, then we're going to go, and that's the smallest ones, so we're going to go with str color equals, what was it? It was Azure. Okay, and then I'm going to say elif FL scale is greater than 1.9, and that's enough accuracy for this, and FL scale less than 3. I'm going to say 1.5 here, 1.5, 1.4, and I'm going to say is greater than 2 or less than 2. Then we'll say str color equals light cyan, copy and paste that just to make it easier on myself, and then else any other scale str color equals, and we're going to go with pale turquoise. Okay, so, and then what we can do here is we can save ourselves a step here and just directly change the color of this. We don't need a variable. Actually, I changed my mind. Well, since we already have that here, let's just change the color right now. Color, str color, there we go. And so now we've got the scale, we've got the color. Now we just need a random location to start. So we can say X location equals random dot randint, and we're going to go between negative 400 and positive 400. And Y location equals random randint negative 400 comma 400. Okay, that should give us an X and a Y location. So now we just teleport. And I'm going to do and one more thing. I'm going to set the snowflake at a random degree to start. So I'm going to say, first I'm going to teleport to X location, Y location, and set heading. I'll just put the random function right in here, random dot randint 1 and 360. So it'll choose a random integer and set the heading to that direction. So now let's check this out. Let's run this and see what happens. Okay, so there we go. We have a colorful snowflake happening here. And that looks like the darkest of the 3 blues. So we may have to adjust that down a little bit later. But the other thing that I did not do is set it to fill in that color. So let's set the fill color. Begin fill, and actually begin fill and end fill, those should be outside of that loop. So it just fills at one time. There we go. So let's run this and watch one of those be drawn. It's actually happening right here. You can barely see it because it's very small and very light. Give that just a moment. I think it's got about 1.5 more arms to draw. The downside to these snowflake shapes is the number of details makes it go a lot slower. Okay, and there's one right there. Okay, wait a minute. What we've got here is another darker shape being drawn right on top of it, and that just happens to be um, the location that was chosen there. It is random, so you will have those drawn on top of each other, but it does appear to do what it's doing. I'm going to pause for a moment, and I'm going to let this run for a while, and then I'm going to show you the end result after it's run a little bit. Okay, so after letting this run for a little bit, you can see sort of what's going on here. And you can see we're drawing some of this quadrant, and we don't have great coverage yet because it hasn't drawn that many snowflakes. But if you let this run, gosh, for an hour, you'd have quite a few little snowflakes. You can also remove some of the detail if you want it to run faster. But you can kind of see what it's doing here, and you can see that I've got it printing the coordinates down here just so I can kind of check and see where it's printing some of these. And some of them are quite light, but the end effect of all of this is that it's going to have the appearance of, the snowflakes kind of having depth. And if you're in a snowstorm, obviously the snowflakes that are further away are smaller and a little bit lighter, and it should have a pretty nice effect when it's all done. But this is how you can use nested custom functions, or custom functions that call other custom functions, to create a relatively simple, and you can see here that the main loop of this program is fairly short. And we've got a lot of randomization going in here to produce some interesting things. And of course, there's lots of things that you could do to customize this or make it your own. So have fun, play around, and keep on learning.